Hello all, my name is Vatan Sharma. I'm a geotechnical support engineer in Midas IT. On the behalf of Midas IT, I welcome you all for this tunnel webinar series that is Advanced Numerical Modeling Techniques for Tunnel Analysis.
So first we talk about the introduction, that is the shield TBM theory, and the second topic in the introduction is the load in the shield TBM. After that we'll see the methodology, that is in the methodology we see the workflow process, model layout, what is the model layout and its descriptions, and in the model we'll see how we do the geometry modeling, how we do the meshing, loading and the boundary conditions. After finishing the demonstration and this part of this webinar, we'll move forward towards the results part and after the Midas GTSNX exclusive offer. So we'll start the introductions. So first, what is the shield TBM tunneling method? Shield TBM is a boring technique that consisting of a protection shield and the trailing support mechanism. So here is the shield, and beneath or behind the shield there is a support mechanism in which we provide the support through the segment, that is the permanent liner. Your shield will act as a temporary liner in the TBM, which prevents the soil from the displacement caving inwards. Okay. Now, what are the loads in the shield TBM? So there are different type of loads. So first is the drilling pressure. When the shield TBM excavate the tunnel, after certain excavation, the cutter head provides the support to the face pressure. That pressure we are saying that the drilling pressure. The second is the jack thrust. So what is jack thrust? When TBM tries to move towards the forward direction or towards the excavation direction, that TBM applies the force on the existing segments which we already installed. Okay, so this is the jack thrust. We also have different kind of pressures like shield pressure, that is the pressure which is account for like maybe the water pressure. This is apart from the overburden pressure. And the fourth pressure is the segmental pressure. The segmental pressure includes the grouting pressure, because first we install the shields, then we remove the shields and fill the grout there. That pressure applied to the segmental lining, that is the segmental pressure. Now we are moving towards the methodology. So in the FEM methodology, in any model, like it is the 2D model or a 3D model, first you have to create a geometry. What you can do, either you can import it from any CAD software or you can create it in the software itself. Then you have to define the material. You have to choose the material according to the site conditions and the project conditions. Let's say if you are working in the 3D TBM model, then you require the 2D segment or a 3D segment and a 3D property, or that is of like concrete. So that is the concrete material. And for the ground, you can choose the material models like if it is a soil, then you can go for the Mohr Coulomb. If it is a rock, then you can go for the generalized ground. So here we have to define the materials. According to the material, according to the project conditions, we have to define the properties and the model conditions. So different properties may be required during the modeling. Either it is 1D property, which includes like truss, beam, and 2D property, which includes shell, plane strain conditions, and the 3D property, that is the solid property. After defining the properties, we have to go towards the meshing. In the meshing, we provide some like we can do in our software, we can do the meshing with the auto mesh functions, and you can also provide the mesh controls. After defining the meshing, you have to define the load and the boundary conditions. Then you have to do the analysis, then the results. So now this is the model layout. The tunnel diameter is about the 10 meter. So this is the tunnel diameter, and the permanent liner thickness is of 0.4 meter. The permanent liner thickness is the segment thickness. So the segment thickness is 0.4 meter. This is the model in which like these are the excavations which is of somewhere around 2 meter, and this is the tunnel excavation area, and this is the liner area, and this is the complete model in which the width of the model is about 30 meter, the height of the model is somewhere around 80 meter, and the cover of the tunnel is about 35 meter. Now, how we create the model? So we'll discuss it in the geometric modeling. First, to create this type of model, you have to create a 2D geometry, and with that 2D geometry, you can convert that 2D geometry into the 3D geometry with the help of extrude option available in the software. Okay, so after the extrusion, your models look like that. After, you have to create the 2D faces with the help of these 2D faces. You have to cut this solid in the different length. So that is the particular, you can say, the round length or the excavation TBM excavation length. In that is a 4 meter in one length, 4 meter in one length. And so after creating these surfaces with the help of cut options, we can create this type of solids. So this is the one solid, and these are the multiple solids because we cut the solid with this surface. And in the process of cutting, we also cut the segments. So there are these are the tunnel sections, and these are the segment liners. Now, after the geometry, we mesh the entire solids with the 3D automatic mesh option. So we mesh the tunnel excavation, then we mesh the segmental liners, and with the help of extract option, we also model the TBM shield. So what is TBM shield? TBM shield is generally like steel plate kind of things which supports the excavation initially. That is a temporary liner which we already discussed in the first slide. So this is the complete 3D model. Now, after the geometry and after the meshing, what we have to do, we have to provide the loading conditions. What are the required load in the model? So we already discussed 3-4 types of load will act in the TBM sheet. That first is the jack thrust. We already discussed what is the jack thrust. So the jack thrust is about the 1400 kPa, which is applied on the segment, not on the tunnel excavations. Then the second is the face pressure, or you can say the drilling pressure, that is about something 200 kilonewton per meter square, which is the load that is provided by the cutter head to support the excavation. Now, the next loads are segment pressure and the shield pressure. So shield pressure are the you can say the additional load other than the overburden load, and the segmental pressure is the grout pressure load. Now, after defining the loads, we have to define the boundary conditions. So for the boundary conditions, here to provide the static boundary conditions, we use the automatic boundary constraint, which we'll discuss in the demonstration part. And we also use change property option that is very useful for these kind of projects. In the change property options, we change property boundary conditions. What we can do, we can convert the mesh property from one property to the another. So initially, my segment is of soft rock or the soft soil. Then it will convert to these segments. Okay. Now, the change property to the steel to grout. So in TBM, what generally happen, like first we apply the shield, then your machine will move forward, then the segment will apply. After the application of segment, your shield will gone. Then we have to fill that area with the grout. So we are changing the shield property from steel to grout. Okay. Now this is the construction sequence. Total 12 stages are there, and we have done the nonlinear static construction stage analysis, in which the activation of liner elements and the various loads based on the advancement, and shield material property, and the ground property, or you can say the segment property, is changed from the original properties to the like steel and the concrete. Now we'll go towards the modeling part, or in the demonstration part. So this is the model. Okay. So in this model, what first we discussed, that first we have to create the geometry. So to create the geometry, first we create the line geometry, then we create the solid from the extrude options we have. After extruding the solid, we have to cut these solid with the help of these faces, or you can say the 2D plates, so that there is a particular excavation, or the length of entire solid is divided into the particular length, that is the excavation length, in one go. After creating these solids, we create the entire model in the solid. These are the segments, and these are the tunnel excavations, and this is the outer ground. So in this model, we are going for the solid segmental lining rather than the 2D shell segmental line, because we are providing 2D shell for the shield, not for the segmental lining. Okay. So after that, after the completing the geometry of the model, we have to create the meshes. So in the meshing, what we do, we'll go for these 3D automatic mesh, and excavate, or you can say the create automatic mesh for all the solids. So if I hide the ground, then you can see. So these are the tunnel sections. If I hide all the meshes and show it to you one by one. So these are all the tunnel meshes. So this is tunnel excavation 1, and this is tunnel excavation 2, this is tunnel excavation 3, tunnel section 3. And we also provide liners in the form of solid elements. So these are the liners, which are the segments of the tunnel sheet. These are also a solid property, so we'll mesh it with the help of this 3D automatic mesh. And we also provide shield here, the shield plate. We also model the shield. So this is the shield, and the shield is we use as a shell element. So if you want to check the properties, the soil has a 3D property, liners has a 3D property, shield has a 2D property, and grout has also a 2D property. So after defining the meshing, we have to define the different kinds of loads. So I'm hiding these all the meshes, and unhide all the solids, that is the main tunnel and the segments. So first we have to apply the load, that is the phase pressure. So hide these segments, and let's say hide this phase pressure. So how you can apply the loads, different kind of TBM loads in this model. So to apply this, go to the static slope analysis tab, click on the pressure. So in this software, you can apply the loads on the solids as well as the mesh. So if we apply the load on the 3D solids, that will automatically convert or automatically apply to the entire mesh. So how you can apply it? So select 3D phase, select this phase. Let's say the pressure is something 250 kilonewton per meter square. So that is the phase pressure. Okay, so apply this, click on apply. phase pressure 1, let's say. So this is phase pressure 1. And similarly, let's say after 2 excavations, then to close it. Let's say after 2 or 3 excavation, it has to apply it on the second load. Again, click on this pressure, click on the phase, select this, enter 250 kilonewton, name it as phase pressure, or you can choose it from here also, phase pressure 1. Here, the low pressure is phase pressure 2. So similarly, you can apply all the pressure loads, that is the phase pressure loads, after every 2 segments or after every 2 excavations, because in one go we are assuming that soil excavate or the TBM excavate this much amount of like this much length of the tunnel. So this is the 4 meter. So this is about the phase pressure. Now we have to apply the shield pressure. So how I can apply the shield pressure? So hide this, unhide all the segments. So to apply the shield pressure, first we have to select, let's say after first go or after the first excavation, first 4 meter excavation, we have to apply the shield pressure. Click on this pressure. My shield pressure is of 50 kilonewton. So this is the 50 kilonewton. Name it as shield pressure 1. Select these. So this is shield pressure 1. So this is for the shield pressure 1. Apply it. Sorry. So this is on inward direction. So click it. This is the pressure acting because of the water level water. So this is 50. So this is minus 50. That is shield pressure 1. This is in inward direction. Again, select the second segment or second segment inner phase. Name it as shield pressure 2 and apply it. Select the next shield pressure and name it as shield pressure 3 and apply it. Similarly, you have to apply the segmental pressure. So I already defined the different kind of pressure which I directly showed to you. And the one important pressure is the jack thrust, which will apply on the segment lining. So how we can apply this jack thrust on the segmental lining? Click on this pressure. First, hide these solids like these two, this solids and this solid, this solid, this solid. Okay, hide it because after one excavation, the TBM pistons will apply that pressure on the segments. So click on this pressure, select the phase, and this jack thrust will apply on the segment lining. So that is somewhere around 4500 MPa, 4500 MPa. So that is jack thrust. Let's say name it as JT1, and select these pressure. Select this phase and apply. So this is the jack thrust applying in the backward direction because TBM tries to move in the forward direction. So that is the jack thrust 1 and this is jack thrust 2. Apply it. This is jack thrust 3. Apply. So this is how you apply the jack thrust pressure on the segmental lining. So I am hiding all these pressures and directly shows you in the existing model. So the first pressure is the self weight. The second is the drilling pressure, or you can say the face pressure. So how you can see it, this is the pressure, the HP1. HP is the drilling pressure, or you can see the face pressure. Similarly, how you can see the jack thrust. So this is the jack thrust. Jack thrust value is 4500 kPa. Now, this is for the second segment. This is the third JT. This is the jack thrust 4. This is jack thrust 5. This is jack thrust 6, and this is the last jack thrust. So in the one go, TBM excavate the 4-meter length. Then again, when the TBM tries to move towards the forward direction, then it applies the jack thrust on the segmental lining. So these are all the jack thrust force. Now, what are the shield pressure? So these are the shield pressure. So what is the value of the shield pressure? These are the perpendicular force acting on the in the direction of inward direction, that is of 50 kilonewton per meter square. And lastly, the segmental pressure. Okay, so lastly, the segmental pressure. This is the segmental pressure. The segmental pressure value is the 1000 kPa, that is also acting in the inward direction, that is the pressure acting because of the grouting. So we are assuming that when the grouting will occur in the field, then the 1000 kPa pressure will act on the segmental lining. So these are all the pressures, and lastly the self weight. So after defining these all the pressures, meshing, and the geometry, we have to create the construction stages. So how we can create the construction stages? Unhide all the solids, hide all the solids, and unhide all the meshes. So there are two ways to create the construction stages. The one is the manual construction stages, and second is the automatic construction stages through stage wizard. So first I show you the manual construction stage wizard. Manual construction stage, how to define the manual construction stage. Then we'll go for the construction, we'll check how we can define the construction stage through the stage wizard. So for the manual staging, what we have to do, we have to go to the static slope analysis, click on this stage set. We already have defined construction stages, click on it. So when you click on it, this type of window will open. So in the initial stage, you can see all the tunnels, all the rock and the tunnel sections and the lining sections are activated. Just give me a minute. Okay. Then after in the first excavation, all the liner, the outer solids, the lining solids, and the tunnel section, these two sections, because we are assuming that the TBM excavate at least 4 meter in one go. So we deactivate these these data sets, these mesh sets, which are including the liners and the tunnel excavation, and we apply the shield here. So the shield, we apply the shield here, and we also activate the shield pressure and the drilling pressure. So shield, when we apply the shield, the water pressure or any other load except this overburden load acting on the shield, and there is a pressure called drilling pressure or the face pressure that is supporting my face. Now in the second excavation, again my outer lining, the solid lining, these solid linings and these two excavation again removed, and my shield activated, third shield and the fourth shield is activated. If you want to see that clearly, we can hide the rock. Now you can see after the second excavation, the shell element, the shield element will activate it. Now in the third construction stage, my shields are activated, next shields are activated, and the next excavation is done. So this the liner solids and the tunnel sections is deactivated, but my lining elements, these are the solid elements, are again activated with the and the property change conditions, that my property is changing from the ground, or you can say rock, to the liners. So this is also activated. And what are the loads are activated in the third conditions? The shield pressure is activated. So this shield pressure 3 for this purple lining and for this gray lining, and HP3, that is the drilling pressure. So drilling pressure 3 is activated on this face. Now, the JT is of JT1, that is the jet thrust one, is also activated, that is acting on this solid lining. Okay, because JT when we apply this JT1, that is activated on this. If you want to check it, how you can check it? So you can see when we hide this. So here this is JT1 activated. Now in the next stage, again my liners, the next liners and the next tunnel excavation is going on, and my shield 7 and 8 is activated, while the liners for this second or for third and fourth excavation is also activated, and in the loading conditions my shield pressure 4, so the shield pressure acting on these two shield linings, and JT2 is acting on these linings, on these segmental linings, and my drilling pressure is activated on this space. This is how my excavation is done for all the stages. But the only thing you have to remember here, that after the application of the JT2, we have to deactivate the JT1, and let's say I'm activating the JT2 here, so we have to deactivate the JT1, otherwise an additional load will act on these linings. But in reality, my TBM is on the forward direction and is away from this point, So this is S5, this is S6, this is S7, this is S8, this is 9 and 10. So these are the total construction stages. If you want to check the stage simulation, you can click on here and you can check the simulation stages. So this is how your stage simulation will done. Now, after defining the construction stages, what we have to do, we have to define one analysis case. So here we have to click on this general, select the solution type as a construction stage. You can name it as tunnel analysis, and we have to activate this initial stage for stress analysis, apply K0 conditions, cut off negative pressure, and estimate initial configuration of activated nodes. Then we'll click OK, and we can we analyze it. So I already have the analyze model, so I'm going in the post mode. So we'll see what are the results. So in the results, if I uncheck the ground again, you can see in the initial stage, because there is no excavation and we also cleared the displacement in the first conditions. So these are the displacement. There is no displacement because we cleared the displacements. But we have stresses in the first condition. So this is Fxx, the normal stress in the x direction. This is normal stress in the y direction, and this is the normal stress in the z direction. Now, after the first excavation, this is my total displacement. So this is the deformed shape. So if you want to check the undeformed shape, this is the undeformed shape. This is the total deformations. This is deformation in the x direction. This is deformation in the y direction. So by checking the y direction deformations, you can check how much displacement is in the face. And these are the deformations in the z directions. So in that conditions, because only the shields are activated, so we can also check what are the axial force in the shield. So these are the axial force. It is somewhere around 4 meganewton, and these are the axial force in the y directions. These are the bending moments, and these are the transverse shear forces. And if you want to check the stresses, these are the stresses, the x direction stress, the y direction, and the z direction stresses. Now, if you want to see the vectors, so these are the total deformation. If you want to see the vectors, so these are the vectors for the total deformations and the x direction and the y direction and z. And here we have the stage bars by which you can check the deformations for each stage or any results for the each stage. Now, if you want to check like what are the stresses in the linings, so these are the stresses in the linings. So to check the stresses in the lining, hide these rock and yes, so hide the rock. These are the stresses in the lining because, or you can say the deformations or the stresses in the segment because of the excavation. With the help of these stresses, you can design these segmental linings accordingly. So these are the segment linings. If you want to check the plastic status, so how you check the plastic status in the rock? So initially, this is if. So initially, there is no plasticity. After the two excavation, this is the plasticity. This is after third excavation. This is after fourth excavation, and this is after the last excavation. This is the plasticity. And we also have the options like clipping plane. Let's say if you want to check the results somewhere between the model, you can hide the vectors here. What you can do, you can clip the plane, add it, and hide this always show edges, and you can also check the results. If you want to check the face stability, your face is stable or not, check for TY displacements and check the results. If you want to see the deformed shape, this is the deformed shape. Okay. Now we are again going towards the presentations. So this is the model, complete model. So these are the displacements which we already see. Like these are the results for the displacement. These are the displacement vectors which we are already seen it. And these you will also get the shell element forces. These are the shield forces. And you can also export these results to the Excels. You can also export the word image file. You can also check the multi-step ISO surfaces. And there is one unique feature we have in the GTS-NX, that is the 3D PDF. So you can export these 3D PDFs and check out all the results, like all the contours, without having like GTS-NX. Without having GTS-NX, like you can check the results easily. Thank you for listening us. Have a great day. Bye bye.